Hello, today I'd like to go over Chapter 5, Common Table Expression, how to create a view, how to create a simple function that returns a data set. First, this is subquery. You can have a filter with USA and USA customers. So when you run this one here, you will get a number of records, 13 records. So this is a subquery and it's calling from the data set it returns. So you can test it by running only the subquery like this, and it returns 13 records. Basically, 13 records are all the records are called from this outer query. So this is it, alias name. So this is the data set. This is the alias name, and it's calling from the this alias name, which is same as this one here inside. Assigning column alias. So you can have year and this is the alias name. This is the count distinct and this num customer. Group by orders. So this may fail. The reason is that order year because this is aggregate function and group by this and you cannot grab from here. So you can do by this way. So this is the subquery and or group by order year, which is this one here. So you can calling subquery this data set, run this one here, it returns 831 records. And so this set is this is the inner data set, so order year is passed over here. So that's why you can call this one here and returns data set. You can also do this way, year and this. Also, you can, instead of having alias name, you can put this actual name. Then it will work same way. So 4 records return. This. So first one returns to 4 records, and second one returns 4 records. So once again, only difference is where you have group by. Original one that fails, this one is calling from the alias name. Alias will not work. You have to call directly this one here. So external column IDs, same. Running this, it will work because this data set here inside order, and this is a column alias. First, this order year is referring to the first one, and the customer ID is same as this one here. So this is what you call external column alias. Now let's get to the a little bit more advanced topic. You first declare a variable as symbol and employee ID. So as symbol means it's saying this is a variable and data type is integer and you are assigning value 3. So you simply can run it here and it will not cause you any errors. It completed successfully. You just simply declare a value assigning 3 to a variable called employee ID. Now, when you run this combined with this, so that means you are passing employee ID value 3 into this and getting the result set. If you run by itself right here, it will give you error message, must declare scalar variable employee ID. You get this error because this is one single batch. So you have to run both at same time. Running like this, then it will work. If we try to run it separately, it will not recognize the employee ID variable. Nesting. Let's think about the nesting here. You have one subquery and the second and third. Okay. So you can have many nestings as you like. This is first one here. You can grab this one here running this. It will give you a result 831 records. If you run next nesting, run this, it'll give you 4 records. So it is possible to have a number of nestings in here. You can do this one here, having count distinct customer ID is more than 70. So here you have more than 70, you have only 2 records shows up. See, only 2. So same thing as you do here. Running things, you get same data set. Okay, so you have you can apply do the same thing here, 1 and second. So it is possible to have different queries that they're returning the same data set, as you can see here. So this is the one query, and this is the second query, but they return the same values here. Multiple references. Let's look at the multiple references. I have one query here inside here, and the left join. So this one is data one set here. Okay. If you run this one here by itself, it returns 4 records. So this is calling alias name is cur. So whenever you see cur.this, this means the data set is coming from the first query here. So that's why you put the alias name here. And prev, this is coming from this one here. So this is one data set here and returning 4 records. And this data set's alias name is prev. Okay. Then you do join with the cur and the previous order plus 1. And returning a number of records here. Common table expression. What are the benefits of a common table expression? Common table makes a very simple complex queries like this can be simplified using common table expression. Because one data set, this whole like this, multiple joins, all those things can be set as one data set. And from that data set, you can call it. So it starts with the width, and this is the common table expression name that's the same as this data set here. So if you run inside here, it returns 13 records, and this data set's name is USA customers because you have a filter apply here. You name it USA customers, and you calling this one is go here. So if you call everything from this USA customers, this is same as everything from this table. Okay. So you get 13 records when you run this inside. And when you run whole thing here, you get the same number of records, 13 records. So you can have multiple complex queries inside here, but it can be called by the alias name outside here. So this common table is very useful, simplifying the complex queries. Assigning column aliases, you can do putting alias names, order ID, and for this data set from this table. And once again, this is C is referring to alias name, which is calling this data set. Now you can have group by, so this is a C, and calling this one here, and the bottom one here. Running this, you get that result. So this one is referring to the data set of this, and the I on the bottom one here is calling from the C, which is the data set of this. You can have external alias name. So first one is the when you run this one, you get 2 columns. There's no column names here, and you have a second column, your customer ID. You can put the alias name instead of putting it inside here. You can put the alias name outside here. Okay. So this one is referring to the first column, and this is referring to the second column, which is this. Using arguments, you can put also the variable, declare variable, and you put the employee ID instead of inside here. You put this variable inside and running as a batch like this. So it is possible to have a variable and inside the with common table expression with. Multiple common table expression. This is useful. You can simplify queries. Your first data set here is referred to C1. C1 data set here, 831 records. You can further use a group by or enhance the data set C1 because here C2 is what it means is a C2 is data set of C1. So first one, it returns the data set 831 records. Now you're doing group by and calling that data set here. And whatever this returns will be called the C2. So you can very simplify the queries. Instead of multiple joins, use a common table expression to simplify the query, easier to read. Here, you can have running with this, 2 records returned. Multiple references. You can have year and this is cur. So this inside this one here, running this, it returns 4 records, and the data set will be called the yearly count. And now you have other table joining, which is the here and the cur. This is the data set. Whatever you call the yearly counts is coming from this part. And now you give alias name is cur. And you join with the yearly count, which is referring to the same table, and joining with joining with the same table and plus 1. So you're joining with the previous year, then you get this result set here. So you can compare this is value is this value is this value is this. Recursive common table table expression. This is a little bit advanced topic. When you run this one here first, see the result. So usually this deals with the employee and manager. For example, what is the employees? You have a union joining with uh, HR employees, and the employee common table expression, well, is coming from here. So whatever you call it inside, that will be passed on to here again. So this is the way to find managers because you have a single table that has the one column is called the manager employee ID, and manager column is the second column. Um, in order to see the who is the manager of this person, you can see the manager ID and the employee ID. So you're kind of joining it to find uh, component in a component. This is kind of a little bit advanced topic. A little bit takes time to understand, but this is a way to join with the manager and employee because you want to see the persons and manager next to each other. Okay, this is useful for components. Like if you write a program that calculates the chips, designing it, sometimes the certain chips in a chip and in a chip. So kind of um, it's like yeah, same as the manager and the employee, but this employee is can be a manager to this another person, And this manager can be an employee of another manager. So kind of, yeah. What is benefit of a view? Let's get into view. You can create a view. First, if you have a view, this will drop the view, existing one. Now, how to create a view? What's the benefit of view? View is another way to simplify complex queries. Also, for certain security reasons, you want to use a view instead of regular table. Granting permission to certain users, you grant a view instead of a table for security reason. And complex query can be simplified using the view, just like we use the common table expression. Now, we have a table here, sales.customer table, and applying to USA and creating a view. Run this, view created, and if you run this one here, it gives you only it doesn't have any filter here because you already applied a filter inside the view. So it says the country is equivalent to USA. So there are other countries, but you already applied a filter in here. So meaning when someone selects from this is the already filtered. So this query does not have to apply the where country equals to USA because by default this is the only USA customers because you apply the filter inside. You cannot apply uh, the order by inside the view because this is how it is designed. If you want to apply the order by, then you apply order by after creating a view. It's just outside. View options, there are other options, encryption. Why would you encrypt the view? Well, for certain reasons, you do not want to have hackers get into the view and understand the architect of the tables. By having, if you have a view like this, completed, and if someone says, "Oh, I want to see what this, what is the underneath, what's kind of filters applied," people can see this one here, copy this, they can actually grab the design of it here like this. So they can see what the view is about. And there are times you do not want to expose that filters to the users. So then you apply the encryption. With the encryption, the users will not be able to see the actual query. This, running this, encryption completed. So if someone tried to see the underneath it here, it will not show any the actual query underneath it here. So encrypted text for object sales, this is encrypted. So the user will not be able to see underneath the actual query. Schema binding, why would you apply schema binding on a view? There are certain times you do not, first, you get a better performance if you apply schema binding, approximately 30% better performance versus the without the schema binding. Schema binding also checks underneath the table structures. For example, if you create a view with a schema binding, then someone tried to modify a table, dropping a column underneath it, then it will cause the error message shows up here. Drop column address failed because the more objects access this column. So by having the schema binding, it ties to the actual table. So if the user is dropping or modifying the table, it will uh, it will say there's dependency on this another view. Without the schema binding, someone can modify it and this view will not function. If someone drops the city and the view is without the schema binding, that means this view will not work and it will cause other application to fail. You also have a check option, which is once I add this value into this table, let's say enter this, and if I select this one here, which is it shows no records because the customer ABC is there, but the country is UK, and because the view has a filter of USA only, even though you added a records through the view, this will not show up here. So if someone selects this, and you will not be able to see the records. So by having, and if you have actual tables like from here, it will show one record because the country is UK. So country is UK, that's why the view will not show any records. By having check option to the view, it checks, let's see, apply this, check option, and if someone tried to enter a value, just like above value, say insert this, and this will say fails. Because USA customers, you're trying to insert into this table, into this view, but the view will not return any value because the condition is UK. Um, inside the view is filtering it USA, and the actual value is UK. That's why it fails to insert. Okay, dropping the view. Now let's create a function here. Creating a function, why would you want to create a function? Function will simplify a queries, and instead of writing over and over, you can have a function calling the function and very simple way. You call the name of function and pass the parameter, and this will return a value automatically. So let's say create a simple function here, dropping a function and creating a function like this. So function is created. The name of function is get customers, and is passing a one value is type is integer. And when you create a function, you say create function and name of the function. Okay. So create starts with the create and function. So it starts with the create function, and this is name of a function name, and this is a variable you pass into the function. So actually it passes one value integer type, and it's using the customer ID is equal to this. So whenever you pass a customer ID, for example, you pass a customer ID 1, it returns then you can select from here. So it returns these two columns because you're selecting these two columns, even though the function returns all these columns, you can use whatever you want to view from the data set. This data set returns all these columns, employee, order date, shipping day, but you can select only to see two columns. Now, it can also function returns the data set, but you can also join with the order detail actual table. So it is possible to join with the actual table plus the function data set like this, then returns the 12 records. Dropping, if there is a function, just drop it. Now let's look at the cross join and cross apply all these samples there. So if I run this one here, let's look at how many records that returns. So sales customers table returns the 91 records. Selecting it, 91 records. And second table, sales shippers, returns three records there. And next one returns the 9 records, which is the HR employees, 9 records return. Sales orders table has the 831 records there. Now, if we do joining with this, cross join HR and shipper. Shipper has 3 records. Employees table has 9. So cross join will return how many records? 27 records. That's right. So 3 times 9 is 27 records. That's how cross join works. Now, cross apply. How does it work? Cross apply. Running here and have 27 records. So sometimes useful to have 27 and on top one 27. Okay. Now cross apply top 3. How to display 3 most recent orders for each customers. You can have cross apply and this is the customer. You get the customer information, but inside here you join with customer, which is the C alias name, so which is here, and you're joining with sales order table, which is O alias. So you're joining customer ID using customer ID. You join it, but you have order date descending and order ID descending there. So that means the latest order will be displayed because you use the top 3. Okay? So it's going to show only top 3 records per customers. Running this, so you will display only 3 records per customer. These are the latest orders for this particular customer. You can do the same thing in the SQL 2012 using offset 0 row fetch 3 records. So this is useful function in 2012 because you can apply offset and you can pick not the first 3 records, in this case first 3 records, but you can have um, data set like you're starting with the second lowest, second latest to the fourth latest orders. Well, you can apply 1 and 3. Useful, but in this case, I'm doing the 0 rows fetched for 3. So this would be same as the above condition here, which is top 3. So returning the same data set. So outer apply, look at the outer apply. This first one returns how many records? When you run this one here, 223 records, 223 records. But if you apply with this one here, look at how many records it returns. It returns the 265. Well, when you look at the 22 and 57, you will see that one, the value here, 22, which is null value. So it's like left outer join if we have cross apply. Okay, even though there's matching, no matching records, you will display 22 and 57. So that's how outer apply works. Same as the left outer join. One more time, the function create script for function top orders. You can have the function, and this time it's gonna pass 2 parameters, customer ID and n as int. So both int type starts with the create function and name of the function, and it's gonna pass 2 parameters, customer ID and n. So n is the top how many records you want to return, and based on the customer ID there. So going over here, creating function here. Now you can say top 3. Well, in this case, cross apply and you're gonna pass two values, which is customer ID and how many records you want to return. There we go. So you want to return as the 3 records per customer. So if you see how many records here, 72, 72, 72, you have 3 records returned because you indicated here 3. So if you change this one to be 2 and run this one here, then you see only 2 records per customer. Very useful.